Section 4.4 Isosceles triangles. Before we can start with isosceles triangles, we need to know the vocabulary that goes along with those triangles. The two congruent sides are called the legs. The third side is called the base. The angle that's opposite the base, the angle that forms the base, is called the vertex angle. And the two angles that are adjacent to the base, or opposite from the congruent sides, are called the base angles. The first theorem in this section is the isosceles triangle theorem. Now you need to be careful because there are two theorems that we'll be dealing with sometimes get confused by students. When you're talking about the isosceles triangle theorem, you're starting off with an isosceles triangle, which means that you know that the two sides, at least two sides, are congruent. So the isosceles triangle theorem says, if two sides of a triangle are congruent, then the angles opposite those sides are congruent. You're given that the two sides are congruent, and that means that this angle and this angle are congruent to each other. Those two are the angles that are opposite the sides. The second theorem is the isosceles triangle theorem converse, but we call that the base angles theorem. And that's because you'll be given the base angles. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So in this one, base angles theorem, you are given that you have two congruent angles. And then the sides opposite those two congruent angles are also congruent. We also have four corollaries in this particular section. The first one is an equilateral triangle is also equiangular. Think about a triangle that has two congruent sides. Using the isosceles triangle theorem, that means that the angles opposite them are also congruent. And since it's equilateral and all three sides are congruent, that would mean that all three angles could be considered base angles, and they would also be congruent. The second corollary says an equiangular triangle is also equilateral. Think about the base angles. If the base angles are congruent, the side opposite them are also congruent. And that could be said for any of the three angles of an equiangular triangle. The third one is a real kind of corollary. That's a real duh, of course it is. An equilateral triangle has three 60-degree angles. And that, of course, you can prove using the triangle sum theorem. The last one is just a little bit trickier. The last one says, the bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. Let's take a look at the picture that's given here. If I have a bisector of the vertex angle, which in this case the vertex angle would be angle B. If I have a bisector for angle B, then I should be able to use that particular information in that definition to prove that triangle ABD and triangle CBD are congruent. And then using CPCTC, I should be able to prove something about angle BDA and BDC. Before you start doing the notes on the note sheet and doing those problems, I would like you to complete a proof for this particular corollary.